So we are going to find real zeros of polynomial functions using long division. Let's start by dividing x squared plus 3x plus 5 by x plus 1. Right, so we have to find a number that multiplies to x and equals x squared, which is x. So now you multiply this x by x plus 1. So it's x squared plus x. And we subtract this and we get 2x. Drop the 5, so it's plus 2x plus 5. Now we have to find a number that multiplies to x and equals 2x. This is 2. And we multiply 2 by x plus 1, 2x plus 2. And then you subtract this and you get 3, which is the remainder. So now we're going to use something called the division algorithm. The formula is f of x over d of x times q of x plus r of x. Or you could divide the divisor to both sides, so it's f of x over d of x equals q of x plus r of x over d of x. So now let's put our equation into division algorithm form. So first let's take our dividend, which is x squared plus 3x plus 5 equals the divisor x plus 1 times the quotient x plus 2 plus the remainder 3. Or you could also write it as using the dividend x squared plus 3x plus 5 over x plus 1, the divisor, equals the quotient x plus 2 plus the remainder 3 over the divisor x plus 1. Let's do another example. Let's divide 8x cubed minus 1 by 2x minus 1. This 8x cubed minus 1 is missing two terms, so we have to replace those two terms with zeros. So it's 8x cubed plus 0x squared plus 0x minus 1. Okay, now it's like regular long division. We have to find a number that multiplies to 2x, and equals 8x cubed. This is 4x squared. So we've multiplied this 4x squared to this 2x minus 1. So it's 8x cubed minus 4x squared. And then we subtract. So it's 4x squared plus 0x. Now we have to find a number that multiplies to 2 and equals 4x squared. This is 2x. So we multiply 2x by 2x minus 1. So it's 4x squared minus 2x. Then we subtract. It's 2x minus 1. So now we have 1. And multiply the 1 by 2x minus 1. So it's 2x minus 1. And we subtract, get 0. As it turns out, 2x minus 1 is a factor of 8x cubed minus 1. Since 2x minus 1 divides 8x cubed minus 1 evenly, the quotient 4x squared plus 2x minus 1 plus 1 is also a factor of 8x cubed minus 1. So now let's take our equation and use the division algorithm. So let's start by taking the dividend 8x cubed minus 1 equals the divisor 2x minus 1 times the quotient 4x squared plus 2x minus 1. Or you could write it as the dividend 8x cubed minus 1 over the divisor 2x minus 1 equals the quotient 4x squared plus 2x minus 1. So that's how you use long division to find real zeros of polynomial functions.
Okay, in this part of the video, I will be showing you how to do synthetic division. You're going to start by setting your denominator equal to 0. This is going to give you the number on the outside of your brackets, right there. Then you're going to put the coefficients inside of the brackets. You are going to bring down the first number, multiply diagonally, and add vertically until you get to the end. you have a remainder of 68. Since our original dividend starts with an x to the third, our answer is going to start with an x squared plus 7x plus 24. With your remainder, you're just going to put it over the original divisor. Now you just set it equal to the original dividend, 3x to the third minus 2x squared plus 3x minus 4. And you're done. That's your answer. Again, you are going to start by setting your divisor equal to 0. This is going to give you the number outside of the brackets. Right there. We are going to bring down the coefficients. Notice since there is a missing term, you are just going to put a 0 and continue. You are going to bring down the first number, multiply diagonally, and add vertically. Keep doing that till you get to the end. Since our dividend starts with an x to the fourth, our answer is going to start with an x to the third minus 3x squared minus x plus 1. Again, with your remainder, you are just going to take the remainder and put it over the divisor, the original divisor, x plus 3. Set the entire thing equal to the original dividend, x to the fourth minus 10x squared minus 2x plus 4. And you're done.
Oh, hello. Okay, so today we're doing the rational zero test. And what we first have to do is find the possible rational roots. So we find the factors of a constant term and divide it by the factors of a leading coefficient, both plus and negative. So, for example, we have fx equals x third minus 5x squared plus 2x plus 8. So the constant term is 8. So the factors of that would be 1, 2, 4, and 8. And then the leading coefficient is 1. Factors of 1 is just 1. Now, this divided by this would just be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay. So to actually find the zeros, we're going to have to use synthetic division. And you'll only need to find 3 since the leading coefficient is x to the third power. So you set up the synthetic division and you bring down the coefficients. So we're going to use positive 1 for now. Just going to test it out. Right, Kurt? Okay, we're left with a remainder of 6. So we know that x equals to 1 is not a 0 of f of x, and we just keep testing until we find 1. We'll use negative 1 this time. Okay, we're left with the remainder of 0. So we do know that x equal to negative 1 is a 0 of f of x, and we found 1. Okay, so to make life easier on you, you use the quotient from the already found 0. So you set it up equal to 0. This right here, which is x plus 1. And then you bring these down over here. And you're just going to factor it out. And then you're going to solve for x for each one. So you know that these are your x's right here. And if you want to test it out, go ahead. But they do come out to 0 when you use synthetic division.